Hello everyone, welcome back to section 12.3 chi-squared of independence, and in this question we're gonna go over almost a whole problem. So first of all, we're gonna determine the hypothesis testing, then we're gonna find the chi-squared statistics, the p-value, and then we're gonna end up with a conclusion whether they are dependent or independent. All right, so the problem here is wondering whether the dessert, the fact that the customer ordering a dessert and ordering a main course, so these two factors are related to each other or not. In other words, so for example, if somebody order a spicy food as a main course, will that affect his or her choice to get a dessert, whether it's chocolate cake or strawberry cake or an ice cream and so forth? Okay, all right. So for the first question here, the null hypothesis and the alternative hypothesis, they are always the same. They never change. So if I go to your book, this is a screenshot from your book. So again, the null hypothesis is always the same. So H0 for your case is right here, and the two categories are independent. All right, so there is no relationship. For H1, which is the alternative hypothesis, the two categories will be dependent. All right, so this is dependent. So let's simplify our work. And here we're gonna say, so it's saying a relationship exists, so there is no relationship that's independent, right, between the two factors. So the first factor should be ordering an entry, the type of an entry, and the second factor is a type of dessert. And for H1, there is a relationship, or they are dependent. So yes, a relationship exists between the same thing, type of entry and type of dessert. Okay, let's check it. All right, this is actually the hardest part in this chi-squared of independence, is how to calculate the chi-squared statistics, right? For this, we will need the contingency table with all the numbers. So this is our contingency table, and I'm gonna just export it to Excel, right? All right, so once you export the table to Excel, you're gonna see here the type of ice creams, right? Cake, fruit, none. And here the type of entries, which is beef, poultry, fish, pasta, and of course they give you the total on the last column and last row. Please consider that the last column and last row, they are not part of your contingency table. It's only the numerical application, basically the total, right? Okay, so what we're gonna do with this, we're really gonna go to your, basically this is the table from your book, figure 1210, and we're gonna duplicate all the work done in this table, all right? And even the conclusion here and stuff, right? So hang in there just a minute. Okay, so it's still the same table. I just plugged some formulas here. I will get to them as soon as I get to them, right? So let's start with this table over here, right? So the table, this one is representing the observed value, right? So what I'm going to do, I'm going to copy the whole table. And by the way, the observed value is only the value highlighted in yellow, right? So copy this table and let's paste it over here. So whenever you paste it, this is important step. So whenever you paste it as values. So you click on this arrow and you see 1, 2, 3 here. That's the value you want to keep, right? So that's the first paste. This is gonna take all the format away. Since I'm still here on copying mode, I can go and put back the basically the formatting, right? So this is formatting only, so that's good. All right, now all this yellow part, I'm gonna turn it into a different color, and let's go to blue as expected and delete them. So I'm gonna clear all the values. So clear the values. Okay, so I leave only the total values over here. All right, so now how I'm gonna get these expected values. Please notice that I did it differently in the previous section. I think the previous section was easier, but anyway, I'm trying to follow exactly what you have in the book. So for each of these cells over here, all right, so we have basically 4 by 4, all right, for each of the cells, so 16 times. I'm going to multiply the total number of rows times the columns number and divide by the total number n. So the total number n is going to be this one, right? So for example, for this cell in particular, I'm going to multiply 51 times 239 and then divide by 621. So again, I'm going to multiply 51 times 239 and then divide everything by 621. All right, I hope this is clear. Okay, let's clear this out. Okay, so how I'm going to do this, I'm going to click on this cell, I'm going to put equal sign, and then I'm going to select 51. That's the total for the rows. I'm going to multiply it by the total of the columns, which is 239, and then divide everything by 621. Okay, so now I'm going to try to use a translation feature in Excel. So the 621, it has to be locked. So how can I lock it? Is F4. So in my keyboard is function and F4, right? So that's going to put a $sign in front of the letter and $sign in front of the number. You can even type literally the $sign in front of letter and number, and that you're going to lock it. Okay, great. So this is going to give me this number. So this is the expected value, first one. Now I am supposed to repeat this process eventually for everything, right? So what I can do here, because, well, I can go one by one if I want to. So equal sign again, and this is going to repeat the story, right? Click on 51 times shift and 8, 124, and divide by 621, and I'm going to lock 621 again. So F4. Okay, that's one option you do it one by one. However, you can go back to this cell here, all right, and then you can shift it horizontally. So if I want to shift it horizontally, I want the 51 to be locked as well. So what I can do, I can click on F11, that's 51, and I do F4. So that's gonna lock it. Enter, I get exactly the same number. Now what happens if I translate it to the right? Only the column totally gonna be changed. So you can see here I'm using 66, right? Okay, now my objective is to take the whole column here and translate it downward, right? So for this purpose, okay, so for this one I didn't log anything, so you can see the formula have no $sign. What I want to do, I want to translate it vertically, right? So I'm going to lock only the 239 and then I set the 51 free, right? So I'm going to do so this is function F4 and done, and you can see here I can translate it downward, right? So if I click on the last one, you see is accordingly 403 times 239 divided by 621. Okay, I can do the same thing for the other things. All right, so that will be perfect. I'm gonna go one by one. I'm gonna unlock the 51 right now and then lock the 124 instead. All right, and there you go. So then I'm gonna translate it downward, and this should give me, no, something wrong here. Yeah, both of them, they're locked. So let me see again. So this one should be unlocked. Okay, now it should work. So I'm going to do exactly the same thing for the rest, right? So you might notice here that whenever you click to unlock this, you might click on F4 several times, right? So every time you're going to change the locking cells. All right, so stop at F11 without any $sign. And for the other one, you just click once. All right, enter, and there you go. All right, great. So now this will be our table, the expected values, right? Now we get the expected values, we get the observed values, and we're done with this formula. Now what we're gonna do is we're gonna calculate the chi-squared stat, right? So for this purpose, what we're gonna do is we need to calculate this expression. So f0 minus fe, all right? And then what we're gonna do, we're gonna square it, and we're gonna divide by fe, and finally we're gonna do the sum of all the cells, which is really a long way. Okay, great. So let's do this step by step. So the first step is to do f0 minus fe. All right, so this is f0 minus fe, and then the next step, we're gonna do it over here. We're gonna do parentheses f0 minus fe, and we're gonna square it. So here are gonna be the squares of this, right? And me put it together. All right, so let's start with the first one. So the first one is really simple. Equal sign, you click on the observed value, which is this one, minus the expected value, which is this one. All right, and enter. You're gonna give you a number, you're gonna select that number, you're gonna drag the box 4 to the right, since you have 4 units here, and then you're gonna grab it again, and you're gonna drag it down 4 down, as many rows you have, right? And those are the values you are looking for. Now I'm gonna square it, and let me do on the same time divided by f0 as well. All right, so like that would be better. Okay, so what I'm gonna do, I'm gonna do equal sign, I'm gonna select this value, I'm gonna square it, shift 6 and 2, and then divide by the fe, which is this one. All right, f expected, and enter. And this is going to give you this value, and we're going to do exactly the same thing to regenerate the other values. All right, so we're going to select this box, we're going to grab the square on the bottom, we drag it 4 on the right, and then we grab it again, and we select it, we drag it down 4 down as well. All right, so this is going to give us this expression over here, right? So now what we want to do, we want to calculate chi-squared stat. So I stole this table from your book. It's exactly the same thing. So I'm going to go to chi-squared test statistic. I'm going to put equal sign, and then I put the sum here, open a parentheses, and you should go back to these values and select them all. All right, and enter. And this 85.92, it should be the statistical value that you are looking for. All right, let's go and verify it. So we say this is 85.92, and I think they want 2 decimal places, 93 then. Check it. Okay, great. Now they are asking for the p-value. All right, so the p-value of this, And I'm going to show you here the formula, how do you get it directly, right? So now, before going further, let's fill up this table. So the number of rows, there are 4 rows. You can read it on the table. You have 4 rows and 4 columns. So this is 4 by 4. So 4 enter, and this is number of columns 4. And this is degree of freedom. So degree of freedom, this is the formula. You just multiply the number of rows minus 1 times the number of columns minus 1. So this to make it easier, even for the next problem, you're going to use the same formula. You can copy literally this table. So you're going to put equal sign, open the parentheses, click on 4, minus 1, close the parentheses, multiply it, shift 8, open the parentheses, and number of columns, which is 4, got there, minus 1, and multiply it, and that's going to be 9. All right, so how do we get the p-value then? All right, so once we determine the degree of freedom and we have the chi-statistic, right? So remember, the p-value is generated from the chi-statistics. They are almost same thing, one expressed in probability terms and the other one expressed in numerical values, right? All right, so we're going to use the book here. You have two functions that you can use on Excel. So the first one, chi-squared inverse RT, that's a function, and the other one is chi-squared distribution RT. All right, the inverse RT, that's the one that's going to give you the critical value, right? So inverse RT, critical value. The one distribution RT is going to give you the probability value, which is the p-value. So that's what you're going to use. You're going to just put equal sign. And how do you find it? I don't even remember it neither. So just, you know that you are in chi-squared. So type in chi. All right, there you go. You have a function there. You just have to remember which and which. So chi-squared distribution RT. So right tail, RT is for right tail. Don't use the other one. So you're going to select it. Now it's telling you what is X. X is the statistical value. Click on it, comma. And it's asking you for degree of freedom, and degree of freedom is 9. You either type 9 or click on it, and you're all set. All right. So this is going to give you the value. So now you have minus 14. What the meaning of this, right? So that's basically a 0, right? So if you expand this, all right. So yeah, this is basically 1.06, 10 exponents minus 14. So you divide them by 14 zeros and 1. All right. Can you see it as a numerical? Yes, probably. Yeah, there you go, 0, 0, 0. And if you want to increase this, you can put this one further, and you can see the first number that you can see only after 14 zeros almost, right? Okay, this is your value. So the value is 0. All right. Let's go and plug it in. So the p-value for the chi-squared here is going to be 0. You want to do 3 decimals, so 0, 0, 0. Check it. We're good. All right, so how do you make a decision here? Let's go to the whiteboard and try to put everything together. So for this question in particular, we have the alpha equals to 0.01. All right, so the statement that we got for accept and reject on your book is this statement over here, right? All right, so what the meaning of this statement? And by the way, let me emphasize that we get the p-value equals 0.000, right? Okay, now this is accept 80, reject 80 accordingly to the chi-squared stat versus the chi-squared alpha, or critical, right? So this is critical. So now what does mean? We have a rejection zone over here, 80 over here, right? So since the p-value is very small, and remember this 0.00 is an area, it means the p-value, the area of this, would be somewhere really far away here, right? So this is your p-value. So the shaded area here is the p-value, and I am exaggerating there because that is not 0, but let's pretend that is this your p-value as an area. Remember, the p-value and the alpha, they are both areas, right? So now if the p-value stops here, this is literally where, so this is the location of chi-squared statistic, all right? And we know it is around 85, all right? I don't know the exact value, I forgot it, right? So now the problem and the issue is I don't really know the critical value, which is this here, and that is related to the alpha. So instead of comparing the chi-squared critical versus chi-squared statistic, I'm gonna compare the p-values and the alpha. So as an equivalent statement to this, all right, reject 80 if the p-value is very small. So here we are obviously within the rejection zone, right? So if the p-value is smaller than the alpha, then reject. Otherwise, do not reject. Okay, so this will become our equivalent statement that we're gonna use for this. Every time they don't give us the chi-squared, and I mean, you can go to the table and look for the critical value, all right? You have a degree of freedoms and you have the alpha, but since we are here already, so we can go directly and use this statement in our favor, right? Okay, so how do you put it on Excel? So before this, I'm gonna add the alpha value here, which is 0.01. And then I'm gonna go to my decision, and in my decision, I'm gonna use the equal sign. I go to the function mode, and I'm going to use the if statement, right? If, open a parenthesis. So your logical statement here, we said if the p-value is small. So if this p-value is less than the alpha value, you put a comma and you put the statement that you want. So what you're going to say, reject is 0, right? So the statement here has to be between quotes, all right? And then you put a comma and you put the otherwise statement, and the otherwise do not reject the null hypothesis or 80, right? And don't forget to put the quotes and then close and enter. And this is going to be like automatic, all right? So that's how you end up with this, right? Okay, so we're gonna put the statement here. So since the p-value is less, so you have to select less, then the level of significance, that's going to be the alpha. What we are going to do, we're going to reject it, and the null hypothesis, and conclude that, okay, so if we rejected the null hypothesis, therefore they are dependent, right? So there is a significant relationship, right? And check your answer, and that's all.